Alright, time to check out lesson 9.4 for geometry here. These are the new vocabulary terms talking about some special right triangles, more specifically these two types of special right triangles. What makes them so special, you might ask? We're going to find out. So make sure as well you're using some extra examples in the book to help you with the classwork here. I think that's going to be really helpful on this lesson for sure. So let's check out, first of all, our two new theorems. This pen still skips on me sometimes and I don't know why. But here are the two special types of right triangles that we're talking about in this lesson. So one of them is the 45, 90. I'm going to put little degree marks in here too because it's 45 degrees, 90 degrees. This is the 45, 45, 90 triangle theorem for short. And this is theorem 9.8. And then over here we're going to have the 30 degree, 60 degree, 90 degree triangle theorem, or for short, or in short, the 30, 60, 90 triangle theorem. This is theorem 9.9. Alright, so let's draw some triangles that actually look like that. We're not going to measure them absolutely precisely, but I'm going to draw some triangles that actually look like they have degree measures of about 45, 45, and 90. So this one should be isosceles if that's the case. We have these two base angles right here and right here being the same. And this is my right angle right here. So that's the 45, 45, 90, saying this is 45 degrees right here, and saying this is 45 degrees down here. And we know, based on the fact that these are the same, the base angles theorem, the converse of the base angles theorem, tells me that if the base angles are the same, these have to be the same as well. I'm going to call this x, and I'm going to call this x, and I'm going to call this, or what is this? We could use the Pythagorean theorem to actually work this out every time, but these are special kinds of right triangles. So in this case we have a shortcut. So what makes these special, we can come up with these handy little shortcuts. So this would be x, this would be x, and this would be x times the square root of 2. So if this was, say for instance, 5, and this would also have to be 5, and then this one would be 5 radical 2. If this was 4 times the square root of 2, we would divide by the square root of 2 and get what these two are. So pretty handy little tools here. We're going to write some extra things down in just a second with this, but let me draw the other triangle while it's on the line here. So this is going to be 30, 60, 90. So this angle over here should look about half as much as this angle right here. So I'm not measuring that precisely here, but we are going to write that in. So assume that this one would be 60. Assume that the smaller one would be 30 degrees right here. So what's the case right here? This is not the same as this. I hope that's clear to see. But if we called this x, and we called these other sides, we're not sure yet, but if we did Pythagorean theorem, or we would actually use some trigonometry, which is something we're getting to very shortly. Towards the end of this chapter we talk about some trig. We could actually prove that if this was x, if the shorter leg was x, anything, any number, this longer leg would be that number times radical 3, and the hypotenuse would be 2 times that number. So there's some equations that go along with this. So over here, the hypotenuse equals the leg times radical 2. You can see that here. Here's the legs. The legs are x, and then this is x times radical 2. So this is an equation way to remember this. This is kind of a pictorial way to remember this. And then over here we have two different equations. The hypotenuse, we look here, here's the hypotenuse across from the right angle. It's twice as big as the short leg. So it's the short, I'm calling the short leg just short for short. And this is the short times 2. And the long leg equals the short leg times radical 3. these three equations are the big three, you might say, in this lesson. These are the big three equations to remember. Now let's take out a different color, and I want to give you some things that I think are going to help you remember how these pictures look or how the equations go, because this can be kind of daunting at first to try to memorize all these things. We want to have little clever ways. I hope these are clever ways. I hope you find them to be clever ways to remember these things. So I want you to remember here a different color now. The ratios go like this. You have the leg. Both legs are the same. Both legs, the ratios are 1 and 1, and the hypotenuse is radical 2. And let's circle that. So this goes with this one. Over here the ratios are the same as what we see here. You have the short leg, which I'm just calling short. So that stands for short leg is 1. The long leg is in the ratio of radical 3, which is about 1.7, I believe it is. And just wanted to check that. Yes, I was right. So square root of 3 is about 1.73, which would make sense. This shouldn't be longer than this side. So this is about 1. This would be 1. This would be 1.73 times whatever that is. And then the hypotenuse is 2. And the quickest way, the fastest little way I remember this is I just remember 1, 1, rad 2. So I want you to say that a few times. Say 1, 1, rad 2, 1, 1, rad 2, 1, 1, rad 2, 1, 1, rad 2, 1, 1, rad 2. Okay, that goes with this one. It's in the ratio of 1, and let's write this in the different color here as well. This is 1, 1, rad 2. If you don't write that in a different color, it's going to get confusing here. So this is 1, 1, rad 2. And then this one is, I want you to remember this phrase, 1, 2, rad 3. Rad stands for radical. So 1, 2, rad 3. Not radical in the 80s sense of the word, where 1980s, where things, oh, radical, man. No, the radical is this part, the square root part. So this is 1. This is the rad 3 part, and then this is the 2 part right here. So 1, 2, rad 3, 1, 1, rad 2. Remember those phrases, and that'll help you remember what goes with what. So let's check out some examples here. Now let's start off with a 45, 45, 90 triangle. This one I'm going to put kind of like this. I'm going to say this is my 90-degree angle here. This is all stuff I'm starting with, so I'll put this in black. And this is 45 degrees. I don't think I drew this triangle absolutely perfectly, but hope you see that it looks pretty close there. And I'm saying these are both the same. So again, we don't trust the looks of the picture. We trust the numbers that are in the picture. So I can say that that's going to be true as well. Let's say I had this as 8. Now let's add some stuff in the picture that I could say from there. So I'm going to call this X. Well, I'll just put this in black. So hopefully you can see that. Hopefully you can see that if this is 8, that's also going to be 8. And so what equation are we using here? Well, this is in the ratio. If we have a 45, 45, 90, we're going to use 1, 1, rad 2. So I want to put that here, use a different color to do the ratio part. So this is 1, this is 1, and this is rad 2. So hopefully you can see from there. What am I going to do? This is in the ratio like that. So this one's just the square root of 2 times bigger than this. So this just becomes 8 radical 2. So you can just think of it like that. If you were to prefer the equations or want to write the equations down, we're going to do that all together here. Even if you prefer this pictorial way, we're going to do both ways here. So the hypotenuse is the leg times radical 2. And so we have the hypotenuse is X, the leg is 8, and 8 times radical 2. We can leave out this little dot for multiplication and just say that X equals 8 radical 2. Notice no units, so I'm going to leave those out, but this one is probably the easiest version of all these. So if you have 45, 45, 90, and you're given one of the legs, just multiply it by rad 2 and you got it. So 1, 1, rad 2. So let's check out another example, a little tougher one here. I'm going to make another 45, 45, 90 triangle. This one I'm going to make the right angle here in this bottom right hand corner. Trying to make the legs the same length as best I can, just eyeballing that. This is 45, 45, and 90. And so now let's say that this is, we know that these are going to be the same. It's the isosceles triangle here. These are always going to be isosceles triangles when we have 45, 45, 90. And let's say this one I don't know, so I'm going to give it the variable y, and this side I do know as 21. So what's my ratios here again? Well, it's in the ratio of 1, 1, and rad 2. So what that means is this is the square root of 2 times bigger than both of these sides here. So what I could do, thinking of this, I can think of this as if I'm going to divide by radical 2, that will get me back to this, because this is the square root of 2 times bigger. In the equation way, we think of it like this. The hypotenuse is the same equation as before, the leg times radical 2. What's the leg in this case? It's y. We don't know. That's our variable. What's the hypotenuse in this case? This time we do know what that is. That's 21. So what are we going to do here? We're going to take this and divide it by radical 2. We want to get rid of what's multiplied by the variable. So I'm going to divide by radical 2. I can put the y in front here on the left side. That's okay. But what's wrong with this? What's the problem with this? We cannot have, look down here, we can't have a radical on the bottom. That's not allowed. That's not in simplified form, at least for us. So let's do this in a different color. Let's take this. How do we get rid of a radical on the bottom? We multiply by that thing over itself. This is like multiplying by 1. So this is just going to change the form of the number and not what it actually equals. And then we'll have here 21 radical 2 over square root of 2 times itself. Anything the square root times itself is just that number by itself. This is like square root of 2 squared, so square root and square will cancel. 21 and 2, if they had a factor in common, I could reduce, but they do not. So 21 and 2, can't reduce that at all. This becomes my final answer in an exact form, simplified radical form. If I were to plug this into a calculator, I could get an approximate answer. So let's do that right here. Let's see what that equals. So 21 times the square root of 2 is this, 29.698, blah, blah, blah. Keep going. Got to divide that by 2, and we get about 14.85. Let's round that to 2 digits. So 14.85 here approximately. There is no units, so I do not include units here. But those are two possible answers. So if they said exact, you'd leave it like this. Approximate, you'd leave it like that, or you'd put it like that. So we would be amiss, we would be just not right if we didn't do one that had 30, 60, 90. So let's do one of those now. So there's, I feel like a pretty decent looking 30, 60, 90 triangle. The 60 degrees here, the 30 degrees going here. That's clearly the bigger angle measure, looking at the picture, and that one's the 90 degree measure. I'm going to say that this is 10 in this case, and I'm not going to give you what these two are. I'm going to say this is M and this is N. And so what equations do we use here? So let's see if you remember the ratios. For 45, 45, 90, it's 1, 1, rad 2. For 30, 60, 90, it's 1, 2, rad 3. You got to remember that rad 3 is about 1.7. So the rad 3 goes with this side, and the 2 goes with this side. So if you can remember these ratios, these problems are really easy. You just have to take this, and this one's going to be 2 times bigger than this one. So all I need to do is take 10 times 2 to get M. All I need to do here is take this times radical 3 to get N. If you didn't remember that, or you won't like the equations, you prefer the equations, we're all going to write that down right now, write down the equations, but we can do the ratio way, or we can do the equation way. So this, the hypotenuse is the short times 2. So here the hypotenuse is M, I don't know yet. The short is 10, and 10 times 2 equals 20. So if you were given this, you would say M would be 20, and let's put some units here. Let's say this is centimeters, so this, just so we get used to writing units here in this lesson, that could happen here. So let's say that centimeters is our units, that would be 20 centimeters. And to find the long is the short times radical 3. And again, here the short was 10, so I just plug in 10. And we have the long is, we're labeling that with an n. So this is the square root of 3, or radical 3 times bigger. This becomes, you just leave it, you put it like that, 10 times radical 3 centimeters. If you approximate that as a decimal, n is approximately, put that into a calculator, 10 times the square root of 3 is about 17.32. And there will be times when you're given one of these other two and you have to go back to these. But we'll do some of those in class. We'll practice some of that. But from here, let's just give you one hint. This hint will help you with a couple of potential classwork problems. These may be problems that you have to do in class or at home if you don't finish them or do them in class. So for number 25 and number 27, see example 4. Oh, no, see example 5, sorry. See example 5 on page 553 for help. And then one more thing I want to do here, just to recap what we just did. So a recap for lesson, and this is lesson 9.4. So a recap for this lesson. Write this down for me to conclude the lesson here. So step 1, you should decide, looks like a terrible C there, decide, that looks better, it looked like an O before, decide what, if you think of the ratios, if you like that better, decide what ratios, or if you like the formulas better, decide what ratios or formulas to use. And then from there, you're going to plug in what you know. If you're using the formulas, I should say, so plug in what you know. And then step 3, the final step, would be to solve for the variable. If you're using the ratios, you're kind of still plugging in what you know, and you're just putting them in with the ratios. They give you the same in the answer in the end. So ratios are the formulas. We'll be practicing both of those ways, and you kind of will get a feel for what you like better in class. But if you like the formulas, they're all there. If you like the ratios, they're all here in red as well. So remember 1, 1 rad 2 and 1, 2 rad 3 to go along with 45, 45, 90 and 30, 60, 90 triangles respectively.